Hello and welcome back, grade 12. Today we're going to be taking a look at a brand new project. This is going to be the second Autodesk Inventor assembly and drawing file that we're going to create in our course, and it's also going to be the last one. This is the table lamp project, and this is a very small assembly, but it has quite a bit of work involved in the modeling techniques. So we're going to be taking a look at what needs to be done first. So we're going to be creating detail view and assembly layout on a D-size sheet, which will include full dimensioning for all of the items. Now this is only a 3-part assembly. You're creating 3 solid models. Part 1 is the spindle. We're going to be creating a third angle projection, which will include a full section through the hexagon, and part 2 is the base, orthographic projections. So that includes the top, front, bottom, and right side sectional view. So we need more than 3 views. We're going to be including the bottom view in this one because we have details we need to show there, and we also need to include a detail view of the corner of the base to be able to dimension the serrations. So this is going to be done once as a typical dimension. And then lastly, we have the leg in third angle projection. So the leg is extremely simple to complete. I will just briefly discuss it, but I won't be doing a lesson on how to create the model for it because it's something that you should easily be able to do on your own without question. And we're also going to be including an assembly view and right side sectional view of the lamp assembly complete with balloons and an overall dimension. So a lot of the terminology that we practiced in the caster is going to be carried over into this project. So this also includes some images that I've taken, and I'm not going to be opening them up in this video, but I want you to go into the module yourself. I want you to click on these pictures and take a look at them. It includes a combination of the lamp parts that I had 3D printed. I have the spindle and the base completed, but I did not print the legs. And I also include the precision machined table lamp, full assembly with the legs and the electrical wiring, plus the socket and the bulb and the shade is all included. And what we're going to be doing is taking a look now at this file called Table Lamp Machine Shop Drawing Sketches. Now this is based off a high school machine shop project that I had completed when I was in high school. And these plans were drawn up by our machine shop teacher. And of course, they're all done with pencil. It is very well done, but what we're going to be doing with this project is modernizing something old. We're going to be taking something old and we're going to be making it current, right, as per the drafting and design and modeling standards that we've learned over the years. So I'm going to be starting with the spindle today. And so this shows actual hand sketches of actual thread types and thread forms. This is a Acme thread. And we're actually going to be creating the actual thread in Inventor. So we're not going to be applying a thread with a hole feature or a thread feature like I had shown in the valve body, for example. We're actually going to model that thread. And when you look at the images in the module, you're going to see that in the one that I had 3D printed, I had actually done that. So I actually 3D printed all of the thread forms as well. So it's a very true representation of what you see on paper as well as what you see in the manufactured product. Right, so we have 2 different types of threads we're going to be including. We're going to be learning a new modeling procedure to create the tapered shaft here. We're going to be using what's called a LOFT. This is on what's called a number 3 Morse taper. So what is a taper? Right, and specifically, what is a number 3 taper? Well, we're going to have to consult some tables and charts and look some information up. Some of the information I look up for you, and some of the information I want you to search online for while you complete this project. So here is the leg. It's a very basic part. It's basically just 3 different diameters at 3 different lengths. And the larger diameter here, right, is basically a perfect semicircle, right? So this has a fillet of 1/4 inch. So you're going to have to draw the diameter, the largest diameter where the fillet of 1/4 inch is, as 1/2 inch. And it's going to have to be extruded 1/4 inch. And then this extrusion, this 0.375 diameter, it's extruded at a length of 1/2 inch. And then this smaller diameter, 0.250, is extruded to 5/16. So that should be very simple for you to complete on your own. So I'm not going to be doing a lesson on this, but I'd like you just to get started perhaps first and just model that leg. Open a new inch IPT file, create the 3D solid model, name it leg, save it somewhere, and forget about it for a while. All right, and then it actually says in this parts list, item number 2, the legs, right? This is aluminum stock. We're going to need 3 of them, and the stock is 1/2 inch diameter, right? So that's exactly what I said here. Don't worry about the length. This is a machine shop instruction. You're not cutting anything off at 5 inches long. You're just going to model it as per the finished sizes you see here. To get started with the spindle, I'm going to begin. It doesn't really matter from where I begin. I could begin here at the largest diameter, or I could begin here at the back, right? It really doesn't matter. So I think what I'm going to do is I'm going to start in the center today. So I'm going to start by drawing an 1.25 inch diameter circle, and I'm going to be extruding it the same length, 1.25 inches long. And I don't need to tell you that I have this image open on my iPad, so that's what I'm referencing as I complete the work. So I'm switching over to Inventor, going to New, Templates English, Standard Inch, IPT, and clicking Create. So we're starting a 2D sketch, XY plane, circle, 0, 0, and 1 1/4. Let's fix that. 1.25. That's what I want. Okay. Finish sketch. Extrude. This is going to be the same thing. 1.25. And I'm going to work a little forward here. I'm going to be creating the 1/8 long, 1 inch diameter on this face. So that's here. Circle, XY 0, 1, extrude, 1/8. And we hit OK. All right, now turning over to the back. So on this face, we're going to be creating a hexagon shape. So this would be done on a dividing head, or also called an indexing head, on a vertical milling machine in machine shop. So what we're going to be doing is looking for polygon, which is found under rectangle. So we're going to select that, and so a hexagon is, and it shows this on the sheet as well, right here. So this is the sectional view. 1, 2, 3, 4, 5, 6. Hexagon has 6 sides. So that's what we're picking here. We're going to find X, Y, 0, and we're going to draw this thing. And I'm going to keep my mouse on X, 0 here, right? Because I don't want this thing disjointed in some odd position, right? I want to keep it straight, like this. So I'm just going to drop it there. And we're going to be creating a dimension from here to here, right? This is going to be 3/8. And it should give me the same thing from top to bottom, right? So that over constrains the sketch. So that's all we need to do for this, right? Now this doesn't really constrain, right? So we're just going to leave this like this. It's attached to 0, 0. I've identified this as 3/8, shows this as 3/4, so this is just as good. So I'm going to finish the sketch, and I'm going to be extruding this shape. This is showing as an extrusion as 3/4 long. Hit OK. All right. Next, we're going to be showing a 2D sketch on this face. Circle. And this one is 1 1/8. So 1.125. Finish sketch, extrude, and this is the same length as the original diameter where I started. This is 1 1/4. And then on the end, this is showing as 0.8763, 0.875, right? Now don't be confused by this. This is a machining tolerance. This means the person who's working in the machine shop who's cutting this on the metal lathe has a dimensional tolerance to work with. So they can be as low as 0.875 or as high as 0.8763, right, to 4 decimal places. I would just draw this nominally, meaning I would draw this as 0.875, right? When we're working in CAD, we don't need to worry about things like that. We just need to worry about being able to apply the tolerance for the machinist. So extrude, this one is 5/8. All right. Now, this is something new coming up, right? We're going to create a simple loft. So what we need to do is create a work plane and offset it from this face. So what we're going to be doing is creating a plane from here, this face, and offsetting it out, and we're going in a positive direction of 2 7/8. Check mark. All right, so there is our work plane. So we're going to be lofting from this diameter to a smaller diameter. So it shows that this is a number 3 Morse taper, right? We know that the major diameter of it is going to end up at 1 inch, but it does not give us a smaller diameter. So what we're going to be doing is going back into this module, and I've created a upload called tapers, which we're going to take a moment and look at. So this is from a machine shop book, and I'm going to zoom in on this, and this is what we're interested in. So basic dimensions of self-holding tapers, right? So this is taper lock, right? So this mates, right? So they call the shaft part the male end, and they call the whole end the female end, right? That's actually the terminology they use. So just saying that. Right here is Morse taper series, right? So we're finding number of taper number 3. And so this tells us the taper per foot, right? So it will taper 0.6023 per foot. And the diameter at the gauge line here, which is A, and the diameter at the small end is 0.778. So we're just gonna go with this number right here. This is gonna be close enough. So we're gonna select 0.778. So we're gonna go 2D sketch, work plane. The work plane is right into the middle. We're gonna go circle XY0, and we're going to use that exact number, so 0.778. Right there. All right, so we're going to go finish sketch. So what we're going to be doing is selecting LOFT. Creates a transitional shape between 2 or more sketches. Select LOFT. We're going to be selecting this edge and this circle. And it's going to preview the loft. So it's going to basically create an extrusion from here all the way to the circle that we've created on the work plane. And we're going to hit OK, and we're going to have it. So remember what I say about work planes. Don't delete them. Just turn their visibility off. So go to work plane 1, right click, left click to uncheck visibility. Now, we do have a chamfer that we need to include on this diameter. It's showing as a 1/16 times 45 degrees. So I'm just going to add that in there. (1/16), and this is going to naturally give me a 45 degrees like that, and we're going to hit OK, and we've got it. Now I'm not getting into the lesson on how to create the threads today because that's going to take a bit of time to model those threads, but one thing that I want you to add on your own, and I want you to put the through hole through the entire spindle. And it says on this sketch, going back, table lamp machine shop drawing sketches. I'm going to add that hole to my spindle, but I'm not going to be doing it in the lesson. I'm going to be doing it after the fact. It says letter Q drill through. So we're drilling through from one end to the other. That's where you see this hidden line passing through the entire length. All right, what size is letter Q drill? All right, so letter series drills are a certain number, right? You're going to have to go on to the internet, scour the internet, find out what number a letter series Q drill is. So you're going to have to go online, consult a drill size chart, find out the diameter, and I want you to add it into your model. You can either do it with a circle and cut extrusion, or you can do it with the point and hole feature. I'm not concerned about which method you use. All I care about, and at no loss of marks, you need to create the tapered shaft the way I showed you with the loft. It could be done with a center line and a revolution, but we've already learned how to do that previously in grade 11 and in the caster project. So I want you to practice using the loft, right? So that is a part of your mark. And before I end this video, because like I said, I'm not showing that Q drill, I've already uploaded the evaluation for this project. And this may change, but if it does, it will change in a very minor way. Most of this is pretty well locked in stone, but if I make a change, I will be bringing it to your attention. So this is here for you to review as well. So this is going to be one of the last term projects before midterms. And it says here in Advanced 3D Model Techniques to use the LOFT feature for the number 3 Morse taper, which is what I just showed you just now. So you're going to have to take a look at the rubric and make sure you're doing things as per instructed to be able to get the full marks. Currently, peer check process is in yellow because it is currently up in the air. So everything else you see as clear and white is a go, right? So this project is going to be out of 70 or 60 marks right now. But I'm going to end the lesson there. So you have your instructions and you know how to get started. So I'll let you get started and I will talk to you soon. Take care for now. Bye-bye.